Welcome to today's seminar. It's the second in our series. Today we have an awesome colleague here with us who's going to present, Matthew Goodrum. He'll be introduced by Lois Wen, and she will moderate the session. So over to you, Lois.
Hi all, welcome to the STS seminar. As John mentioned, my name's Lois Wen. I'm the graduate assistant on the seminar series committee, and it is my distinct pleasure to introduce our speaker today, one of our own faculty, Dr. Matthew Goodrum. So Dr. Matthew Goodrum is a historian of science specializing in the history of paleoanthropology, human origins, and prehistoric archaeology. He holds a PhD in history of science from Indiana University, where he explored the intersection of natural history and marine zoology in 19th century Britain. His research investigates the development of paleoanthropology as a scientific discipline, the historical debates over human evolution, and the cultural context of prehistoric archaeology. Dr. Goodrum is the author of the Biographical Dictionary of the History of Paleoanthropology and has published extensively in leading journals such as ISIS, Paleoanthropology, and the British Journal for the History of Science. His work critically examines key figures and methodologies in the field from early craniometry to the modern evolutionary synthesis. He also serves on the editorial board of the Bulletin of the History of Archaeology and is an advisor for the Leakey Foundation Oral History Project. A dedicated educator, Dr. Goodrum has been a faculty member in the Department of Science, Technology, and Society at Virginia Tech since 2003. He teaches courses on the history of the life sciences, medicine, and human origins, as well as graduate seminars on the scientific revolution and social studies of science. His excellence in teaching has been recognized with the Certificate of Teaching Excellence in 2019 to 2020 and the Favorite Faculty Award in 2016. Through his research, writing, and teaching, Dr. Goodrum continues to shape the historical understanding of paleoanthropology and the broader study of human evolution. So I would like it if we could all just give a warm welcome to Dr. Goodrum, and I'll turn it over to you. Thank you.
Thank you. So thank you, Lois, and thank you everyone for coming. Okay, so my talk today is fundamentally about evidence. It's about how evidence is deployed to support a scientific idea, and how sometimes new kinds of evidence has to be invoked to be able to support the scientific idea. It's also about contested evidence, so cases where the people involved don't always agree on what the nature of the evidence actually is and what the interpretation of the evidence should be. And equally, a subject that always intrigues me, this is also about someone who was wrong, and yet their ideas went on to have significant effects on the development of the field. So, by some chance, not entirely, exactly 100 years ago today, Raymond Dart published a paper in the journal Nature announcing the discovery of a brand new fossil human ancestor. If you read any history of paleoanthropology today, this is considered to be one of the most important discoveries in the science of human evolution. Raymond Dart is in the pantheon of the great paleoanthropologists. But boy, did it not begin that way. He was going to face lots of opposition to his initial claims about this new fossil. And many accounts of this story actually discount much of the debate that actually occurred over Australopithecus. And so it makes a wonderful case study for the kinds of things that I'm interested in. And so today I'm going to be talking about Raymond Dart. The debate over the nature of Australopithecus as a human ancestor, and this related debate that emerged later, but in many ways sort of proved to be important in its own way, the role of tool use in human evolution to satisfy the history of technology people in the room. Thank you. All right, here's Raymond Dart. He's Australian. traveled to England, where he studied anatomy. Really wanted to become a neurologist and study the anatomy of the brain. And his mentors really kind of made it clear it was very unlikely that he was going to be able to get a position in England, and encouraged him to take a newly opened position in a brand new university in South Africa, which for Dort was going to put him not only outside of the European intellectual community, it was going to put him on the periphery of the world. But having few other alternatives, in the 1910s, Raymond Dart travels to South Africa, where he takes over the new Department of Anatomy at the brand new University of the Witwatersrand. And probably would have had a career as an anatomist, professor of medicine, and who knows if we would have heard very much about him. What changed everything? It wasn't long after Dart arrived at the university. It was just being put together. The laboratories weren't even completed. And he felt that it would be useful if the university had a natural history museum. So this would be a resource for the medical students, the anatomy students, and any decent university should have a natural history museum. Apparently we used to have one and don't have one now. And so he's contacting people to send him interesting animal and plant specimens, but he's also contacting mining companies in South Africa to send him any interesting fossils that might come their way. And this is how, in November of 1924, Raymond Dart is going to receive a crate full of fossils, and one of them is this. Several striking things about this specimen. Number one, if you're an anatomist, this was clearly a primate. What was also evident, it was none of the living or known apes. But there were features of this skull that were unusual. I'll toggle back and forth. So for one thing, apes have a very protruding face. So if you've ever been to the zoo, see the chimpanzee, gorilla, or orangutan, their face really protrudes. This face protrudes, but not as much as in most apes. Humans have very flat faces. Secondly, apes have very large canines. The canines here are actually very small, and in fact, one of the most distinctive characteristics that separate apes from humans is teeth. This creature had much more human-like teeth than ape-like teeth. Third, and what's really cool here, I really do have to go here. So if you look at this, this is actually bone. This here is actually fossilized brain. Occasionally, brain does actually fossilize. What this enables Dart to do, he can actually estimate the size of the brain. It is intermediate. It's bigger than a chimpanzee brain by quite a bit. Much, much, much smaller than a human brain. But it's sort of in between the next known human ancestor, the Java man. I'll show you some stuff soon. And apes. But what really clinched everything, the hole in the skull where the spinal cord attaches to the brain. In animals, it's at the back of the skull. In human beings, it's at the base of the skull because we walk upright. The hole where the spinal cord attached to the brain, it was at the base of the skull. This thing walked upright. And this is at a period where apes don't walk upright. It's only humans and human ancestors that walked upright. And so for Dart, he was convinced that what he had found was the intermediate link between apes and humans, which would make this the earliest known phase of human evolution that was known from a fossil, and make this a spectacularly important discovery for human evolution. this fossil changes the course of Dart's career. Here's a more modern photograph of the skull. So he sends this paper off to Nature with an unfortunately, as all the readers of the journal said, with an unfortunately small photograph that really did not give a good impression of what the skull looked like, announcing that he had discovered a new fossil human ancestor that he named Australopithecus africanus, the southern ape from Africa. The following issue of Nature contained several papers on Dart's discovery. Two of them were written by two of the leading anatomists and anthropologists in Britain. The first, Grafton Elliott Smith. So Grafton mentor when Dart was studying in England. It was actually Elliott Smith that told him, you should take this position in South Africa. The other is Arthur Keith. Keith was also trained as an anatomist, but they had both, over the last decade, become very involved in human evolution. They were among the leading theorists in England on human evolution in the 1910s, 1920s, 1930s. Both Keith and Elliott Smith were very dismissive of Dart's fossil for a number of reasons. And these are going to play important roles in the debate as it emerges. Number one, the fossil itself looked very ape-like. In fact, it looked far more ape-like than any of the known human ancestor fossils that have been discovered so far. That didn't necessarily mean it couldn't be a human ancestor. Far more problematic. Almost everyone in the 1910s and 1920s thought that humans had much more likely evolved in Asia than in Africa, for a number of reasons. This fossil was found absolutely in the wrong part of the world. Third, there was no firm information about its geological age, and in fact, estimates for its geological age didn't make it old enough that it could really be a viable human ancestor given current ideas about when humans had diverged from apes. So there was the age problem in terms of geology. But probably the biggest obstacle for both of these men, the prevailing theory of human evolution at the beginning of the 20th century, was that the human brain had increased in size first. And it was the increase in the size of the brain that gradually transformed ape-like ancestors into upright walking bipedal creatures with free hands that could begin to use tools. And so keep this in mind. The brain first conception of human evolution, Australopithecus, it has a bigger brain than existing apes, but its brain size was much, much smaller than the human ancestors that were then known. The brain size is going to be this persistent problem in addition to the very ape-like features of this fossil. And this is what Dart is going to have to fight against for decades. So this is the very next issue of Nature. Most of the scientific community really falls in line behind Elliott Smith and Arthur Keith. In the United States, Alois Hrdlicka was the leading physical anthropologist in the United States. And for the graduate students in the room, this is the correct way his name should appear. There are too many American websites that leave off the diacritical marks. He's Serbian, thus the spelling of the name. Emigrates to the United States. He's at the Smithsonian Institution, which makes him institutionally in one of the most important centers of physical anthropology in America, and really kind of made him one of the spokesmen of American paleoanthropology when the discipline almost didn't exist in America. Turns out that later in 1925, Hrdlicka was going to go on a world tour to investigate all the known human fossils. And so by that summer, he is actually in South Africa and pays a visit to Dort. He is one of the first non-South Africans to actually directly see the fossil itself. Unfortunately for Dort, when he returns to America and publishes his account of his trip, he treats Australopithecus as a species of ape closely related to chimpanzees. And so for Dort, he is beginning to see that there is this mounting opposition to his interpretation of Australopithecus. And then things get dramatically worse when in China, there is going to, between 1927 and 1939, be a whole series of spectacular discoveries made in China, largely by these two men. Davidson Black. So Davidson Black was a Canadian anatomist, studied at the University of Toronto, became interested in human evolution, so went to England to work with Grafton Elliott Smith and Arthur Keith. From them, got this idea that if we want to find the earliest stages of human evolution, you need to look in Central Asia because that's probably where humans evolved. Much like Dort, China, who was trying to westernize at the time, was just beginning to establish Western-style universities. And in Beijing, in 1919, a brand new medical school was being opened, and not only was it based on the Western model of university training, they were also hoping to hire Western professors. Davidson Black was very motivated to try to find the earliest human ancestors. He was convinced by this idea they would be found in Central Asia, needs a way to get there, and now here is this wonderful opportunity. Davidson Black is hired as the professor of anatomy at this new university in Beijing. He is an anatomist, not a geologist. Luckily for him, this is also about the first generation of Chinese scholars that are traveling to the West to get degrees in science and returning to China. Pei Wentong had just returned from Paris with a degree in geology and paleontology. From the mid-1920s, Black, teaming up with Pei is basically conducting excavations in the field, and Black, the anatomist, is discovering what's found, and what they find is a whole collection of skeletons, including 14 skulls of this. Originally called Peking man, later designated Homo erectus. And so if we have modern humans, Cro-Magnons, which were the Ice Age humans, Neanderthals, which are the mid-Ice Age humans, Homo erectus is basically early Ice Age humans. If you look at the skull, large brain, smaller than ours, but a large brain. Very prominent eyebrow ridges, very similar to chimpanzees and gorillas. So there are ape-like features, but very human-like features. It's found with a large brain. It is found in Central Asia, where everybody expected humans to have evolved. Almost immediately, the scientific community embraces Peking man as a human ancestor. But again, only 2 years after Dart has published his paper on Australopithecus, you are beginning to get a flood of these wonderful fossils from Asia, exactly matching people's expectations. And this just kills any chance of Dart's claims being taken seriously by most of the scientific community. So this is partially a matter of timing. What terrible timing to make a really important discovery. Luckily, there were supporters. One of the earliest is a fellow named William King Gregory. Gregory, an American anatomist, paleontologist, expert on apes, just the kind of background that you need to make sense of what Dart's trying to say. He's at the American Museum of Natural History, prominent institution, which gives him some stature. Gregory is going to inspect the Australopithecus fossils, and he is convinced that Dart is probably right. This has all the features of what you would expect a transition from apes to humans to look like. And from the early 1930s all the way up until the 1940s, Gregory is one of the leading voices in America sort of supporting Australopithecus as a human ancestor. More important long term, however, is Raymond Dart. Robert Broom. Scottish. Also emigrates to South Africa. He's a practicing physician, trained as a physician, but early in his career, very interested in paleontology. Turns out South Africa is spectacular for the transition from dinosaurs to mammals. And he was actually known as an expert. Without telling Dart that he was arriving, Broom bursts into Dart's laboratory. Dart's in the room. The fossil is sitting on a desk. Without even saying hello, Broom rushes over to look at the skull. These two men are sort of examining and discussing the fossil. And Robert Broom comes away from that meeting convinced of two things. First, Dart is right. This thing has too many features that are human-like to just dismiss it as being an ape, which is what Hrdlicka, Keith, many others had already done. So he becomes one of Dart's supporters in South Africa. More importantly, though, Dart is not a geologist. Broom, the paleontologist, if we are going to be, and it quickly becomes we, if we're going to convince the European scientific community that Australopithecus is actually a human ancestor, remember, we only have one specimen and all we have is one skull. We need to find more specimens and we need to find more of the skeleton. If we can definitively show that this thing does in fact walk upright, does have other human features, this is going to be powerful evidence to sort of convince the critics that Australopithecus is not some weird southern ape in Africa, but is indeed a human ancestor. And so, Broom, the paleontologist, he begins to search caves, which is mostly where you're going to find fossils. And in 1936, Broom discovers this, a practically complete Australopithecus skull, which gives a lot more detail about what the Australopithecus skull looks like. And it really reinforced these ideas. It has a significantly bigger brain than apes do, has many features in the face and the teeth that are much more human-like than ape-like. This is followed by several other discoveries through the 1930s into the 1940s. And this begins to at least force some paleoanthropologists to take the Australopithecus material more seriously. But it does not fundamentally change people's minds. Dart basically spends from 1925 up until the beginning of the Second World War, which basically stopped scientific research in South Africa as with everywhere else. He spends all that time publishing paper after paper after paper, focusing on the anatomy of Australopithecus, trying to convince anthropologists who are anatomy guys. The anatomy of this creature is of a human ancestor and not the anatomy of an ape. There was one additional piece of information, though, that was beginning to make him think of another approach to tackling this problem of the nature of Australopithecus. In the geological location where the very first Australopithecus fossils were discovered, it was a cave. And again, fossils mostly could have been caves. There were a large number of antelope bone that had been found in this cave. Begins to make the argument, the bones that we're finding in these caves are the parts of an antelope that you would carry to a cave if you were eating antelope. He becomes convinced, what is also one of the big transitions from ape to human It is the transition from eating plants to eating meat. Dart begins to suggest, what if Australopithecus was not only an upright walking, relatively larger brained ape, what if they also ate meat? Here is another feature that makes them more like humans and less like apes. So already by 1929, this is sort of in the back of his mind. By the late 1930s, his responsibilities at the university were becoming quite taxing. He actually becomes dean of the medical school. The war intervenes, and work basically stops. And he's not a paleoanthropologist. He gradually, and the response to his many papers were less than thrilling. He is gradually moving away from work on Australopithecus. It's actually mostly Robert Broom, who's making new discoveries, publishing lots of papers. What changes things is, in 1945, only months after the war was over, a group of Raymond Dart's graduate students make a trip to the Makapansket Valley. As you can see, kind of a beautiful valley, limestone cliffs, and limestone contains caves. On this trip, his students discovered some fossil sites, including skulls. Baboon skulls had also been found at the original Australopithecus site. This gets Dart thinking, have we found a second potential Australopithecus site? And so, at the university in the paleontology laboratory, there was this young man, James Kitching. He was a field worker. So he was not a professor at the university, he was a field technician. He supervised and undertook excavations. Dart encourages Kitching to go to Makapansket and see if he can find fossil animals, and maybe can they find some more Australopithecus fossils. He does indeed. In 1947, and then again in 1948, he's going to find a pelvis, he's going to find a bit of an arm. Guys, this is basically, a whole skeleton is extremely rare. Usually it's bits and pieces that have survived somehow. But there is new Australopithecus fossil evidence. And for Dart, this really pulls him back into, can we utilize this new evidence to get back to my old objective, try to convince people that Australopithecus is a human ancestor and not some weird species of ape. Kitching and also Alan Hughes. Difficult to find an image of Alan Hughes. This is from many, many decades later. This is actually Raymond Dart, shortly before his retirement. Alan Hughes is in the middle. And Philip Tobias, he was actually the graduate student that led that 1945 expedition to Makapansket. Tobias actually succeeds Dart as the professor of anatomy at the University of the Witwatersrand. This photograph is actually on the occasion of Dart's retirement. Alan Hughes was sort of the Department of Anatomy. Dart is basically going to deploy Kitching and Hughes for over the next 10 years to conduct work at Makapansket, looking for any new Australopithecus fossils that they can discover. But the other thing that they discover at Makapansket, a whole bunch of baboon skulls, in addition to thousands of antelope bones. An enormous accumulation of antelope bones in this cave where, again, you would not expect to find antelope bones. Basically, Kitching and Hughes are going to extract thousands of fossils over the next 15 years from Makapansket. Some of them Australopithecus fossils, but increasingly there's going to be a focus on these animal fossils. Initially, what you're trying to do, what was the environment that Australopithecus lived in. And by identifying the fossil animals, you're reconstructing the environment. That quickly changes because it was almost entirely just antelope, and there was this remaining idea, wait a minute, no reason to find antelope bones in a cave unless these were the remains of Australopithecus meals. Two things happened next. The baboon skulls, many of them had been fractured in a very distinctive way, as if they had been struck by a club. Dart's an anatomist, so he knows this, but he's not a forensic anthropologist. The university heads a forensics professor, Ronald McIntosh. McIntosh collaborates with Dart, and McIntosh, who had actually dealt with many murder cases, argues that these fractures are exactly like the kinds of fractures you find when you are struck by a club. And as Dart is looking around for what object would be club-like, he's seeing these antelope leg bones that fit beautifully into the shape of the fracture. Dart becomes convinced Australopithecus didn't just walk upright, didn't just have larger brains, they used tools. And boy, before Jane Goodall's work in the 1960s, only humans and human ancestors used tools inconceivable that apes could. And so now Dart has a whole new direction to move through. On the one hand, all these antelope bones which suggest that Australopithecus must have engaged in hunting. They were hunters, ate meat, lived in caves, and used tools. Boy, if you want a collection of characteristics that define human beings and not apes, that's the collection of features that you would want to find. And so you get this beautiful quotation in a paper he publishes in 1949, when this is just in the first stages of what's going to become a research project for the next decade. I want to unpack some of this. So here's Dart. He was known for his exuberant language, which many of his colleagues later criticized him for. So Australopithecus, they were human. There's another feature here, guys. Modern anthropologists, there are apes, humans, and hominids. Those are the intervening links. There is not yet really a vocabulary of what to call what's in between. For Dart, there is the human end of the human evolution range, and then there's the ape end. I should have mentioned this earlier. Things like the Peking man, they were called ape men. Clearly human, but with ape-like features. When Dart first described Australopithecus, they were not ape men, but they weren't apes. He calls them man-like apes. So they were very ape-like, but with human-like features. The language is going to change. And now here's Dart. Australopithecus, they were human, not merely in being bipedal. So now all those papers that he had published, they walk upright, which humans do. So they are not merely in being bipedal, in maintaining an upright posture, and in having a facial form, that flat face that humans have, apes don't, and dental apparatus, meaning no huge canines and more human-like teeth. They were also human in their cave life. The cavemen of Europe, like the Neanderthals, Australopithecus lived in caves too. Apes don't do that. In their love of flesh, in hunting wild game to secure meat, and employing implements, whether wielded, propelled to kill during hunting, or systematically applied in the, he found all these bones. Many tribal people today but also many Ice Age humans, food is at a premium. Marrow. There are many bones that could be shown to have been cracked open, twisted, broken in half so you could get at the marrow. He was beginning at Makapansket to find all these antelope leg bones that had been smashed, that typical twisted crack that convinced him they were cracking bones to get marrow, in addition to hunting. Now the problem. There is only one physical feature, namely brain quantity, the brain volume, not brain quality, intelligence, which separates these, and they are no longer man-like apes. Now they are proto-men from early man. This is a fantastic quotation because it captures not just Dart's conception of what the Australopithecines were, it also, here are the collection of sources of evidence that should be persuasive, where on the one hand, the anatomical evidence, which had never been sufficient, and now increasingly hunting behavior and tool use, which should overcome what is the main obstacle, the brain being too small. He's got a strategy now. As much new anatomical evidence as we can provide, that's going to be terribly useful. But increasingly now, he wants to be able to defend two things. First, they engaged in hunting. Can we prove definitively that they engaged in hunting and these enormous accumulations of antelope bones were produced by hunting? And secondly, that they used tools. Not strong evidence for that yet, except for these baboon fractures. But this is a possibility in the back of his mind. He is now proposing an entirely new conception of human evolution. In 1953, he is going to publish a paper titled The Predatory Transition from Ape to Man, where he makes the argument the previous conception of human evolution, that increased brain size evolved first, and that led to bipedalism and tool use. He argues that Australopithecus actually disproves this theory, and that instead, apes began walking upright even while they still had small brains, and the freeing of the hands allowed the use of tools, and it was this that then encouraged hunting, but also increase of intelligence, and therefore the bigger brain. And so we go from the brain first conception to now bipedalism first, and brain arises from that. And so this is now the vision of human evolution that Dart's beginning to advocate in paper after paper after paper. And it all depends on those antelope bones being the result of hunting and those fractures to the baboon skulls being the result of tool use. This is where he gets his first pushback: disagreement over evidence. Ralph von Königswald, a German geologist. In the 1930s, he had been hired by the Dutch colonial government in what is today Indonesia to be part of the Dutch geological survey of the Indonesian islands. Von Königswald in the 1930s is going to begin to discover human ancestor fossils very similar to the Peking man fossils I showed you from Davidson Black in Beijing. So von Königswald, he's now a geologist, paleoanthropologist, discovered quite a few fossils advocating this notion of later human evolution in Asia. But after Dart's publications about the Makapansket fossils, von Königswald is going to propose an idea that is going to be the thorn in the side of Dart for years. Von Königswald is going to argue that all of those antelope bones that were found in the caves at Makapansket, they were actually the result of hyena predation. It was well known that Ice Age hyenas lived in caves, and hyenas are animals that capture prey but bring their prey back to their den. Von Königswald presents the thesis: all those antelope bones that Dart says were the result of Australopithecine hunting, they are actually the result of hyena predation and are not evidence that Australopithecus hunted. Matters get a bit worse when Kenneth Oakley, we'll come back to him in a second, but Kenneth Oakley, keeper of geology at the British Museum in London, a paleontologist who had also in recent decades become involved in the human evolution debate. In 1953, Oakley is actually making a trip to Africa to go to several conferences and visit human evolution sites. And so he makes a trip to Johannesburg to visit Dart. Oakley examines the Australopithecus fossils that Dart and Broom had discovered. And in fact, 1953 is now open to the idea that these might actually be bipedal proto-men. He is even open to the possibility they might have engaged in scavenging of carcasses that animals had already killed. He was very skeptical that they engaged in hunting. And he was even willing to entertain the idea that they had engaged in what he called improvised tool use. Wave a stick around, throw a rock. He was very skeptical that they made tools. And boy, we're going to come back to that. And lastly, he fully subscribed to von Königswald's idea that all of those antelope bones at Makapansket, they were actually accumulated by hyenas. This hyena hypothesis, Dart immediately recognizes the threat posed by this hypothesis. And so what does he do? He gets Alan Hughes to go investigate hyena dens in the Kruger National Park in South Africa to determine two things. Do hyenas actually bring carcasses back to a cave, to their den? And if they do, what parts of the carcass? Does it match the parts of the animals that they were finding in these Australopithecus caves? And secondly, crucially, what do hyenas actually do to the bones? Because these were like full bones. And, okay, so Hughes investigates all these hyena dens. Here's what he concludes. Hyenas do not carry huge portions of the skeleton back to the cave. And crucially, hyenas tend to crush their bone. In fact, hyenas can eat most of the skeleton. They crush bone. They don't leave nice pristine bones or cracked bones. And so there are several papers published trying to dismiss the hyena hypothesis. This really shows how crucial this new notion of darts that Australopithecus engaged in hunting. But it's really at this point that Dart really goes full in trying to study the animal bones at Makapansket. And so, beginning about 1953, Kitching and Hughes undertake a statistical study of every bone that they have extracted from the caves at Makapansket. 25 tons of rock is transported from the caves to the university's paleontology department. And they spend years extracting more than 7,000 fragments of bone, horn, teeth from all this material. They end up with more than 4,500 bone fragments. And they do the first statistical analysis of what are the kinds of bones found, what species of animal do they belong to, and what parts of the skeleton exist. This had not been done before. This is standard part of paleoanthropology today. And so this is a major episode not really discussed by other historians. What do they discover? Some surprising things. Number one, overwhelmingly, what you tend to find in caves in other parts of the world, it's bears, owls, hyenas, animals that live in caves. What did they find in Makapansket? Almost entirely game animals, various species of antelope. 91% of the fossils from Makapansket belong to antelope. For Dart, this was overwhelming evidence that this was not the product of hyenas, this was the product of Australopithecus hunting. But what they also found, there were peculiar results on the parts of the skeletons being found. Some bones were much more common than others. For instance, I won't even ask you to make a guess. The most common of all bones were actually mandibles, the lower jawbone. Why in the world would you bring lower jawbones back? No meat to eat. He's going to have an idea about that. The second most common, the upper front leg bone, so the humerus. It's these statistical deviations that for Dart indicate that there were certain parts of the skeleton that Australopithecus was focusing on for meat, leg bones, but there were other parts of the skeleton, like the mandibles, that would be useful as tools. And so now he's not only reinforcing this notion that they engaged in hunting, he is now really becoming focused on this notion that Australopithecus used tools. He's got an argument now. He's been making the anatomy argument for decades, unsuccessful. Now he's got a new argument. In 1956, Dart's going to publish a paper. So what has been the problem? What has been the obstacle to scientists accepting his thesis? Here's his diagnosis of the problem. Ever since the discovery of the South African man-like apes, this business of trying to determine the boundary between ape and man, or expressed otherwise, to define what is and what is not a man, we would today say human, has become increasingly difficult. Well, I'll show you why in a second. Thus, when such creatures as the Australopithecines were found, we, the scientific community, could not know whether to call them men or apes. So what's he getting at? Well, I had to search for quite a while. So these two different images beautifully demonstrate the problem, which didn't really exist this clearly in his generation. So look at the top image. At one extreme end, we have gibbons and chimpanzees. So we know what apes look like. And in fact, that part of the spectrum was known from living apes. What was known in the paleontological record about human evolution is basically only those first three on this end: humans, Neanderthals, and the Peking man stuff. But wait a minute. If we start with an ape-like ancestor, and we are evolving gradually, which was the conception at the time, evolving gradually to humans on this end of the spectrum, this top part of the spectrum is not going to be difficult to interpret. When you find a fossil of a very evolved human-like creature, clearly it's human. If you're down on the ape end of things, they're clearly going to look like apes. But what happens when you get to that intermediate zone? We could find fossils that were so intermediate, they might have just been apes that had begun to evolve somewhat like humans, but did not continue on into the human direction. Or they could actually be apes that were well on the way to becoming humans, but they are so ambiguous, how are we going to be able to distinguish whether we should put this in the category of ape or in the category of human? That is exactly the scenario that we're confronted with today. This is Australopithecus at A, all the way to Homo sapiens way over at the bottom end. Look at how gradual that is. If you're looking at something in the middle, it is not going to be clear, is this just an evolved ape, or is this something that really does sort of deserve to be considered an early ape-like phase developing towards humans? So Dart's argument is, this has been the problem with Australopithecus all along. It inhabits that ambiguous stage that from the anatomy alone, it's really difficult to determine, is this just a strange ape or an ape moving in the direction of humans? Dart's going to make a new strategy. We should not just focus on the anatomy. We need to also focus on behavior. And what's the only preserved evidence for Australopithecus behavior? That's human behavior and not ape behavior. Hunting and tool use. I mentioned Kenneth Oakley just a moment ago. So here's Kenneth Oakley. So again, English geologist. In 1949, Oakley is also, and partially this is because of the Australopithecus debate. By 1949, he was really beginning to think about the problems of human evolution, focusing on anatomy. And he too came to realize paleoanthropologists are probably not going to be able to rely upon anatomy to be able to solve the question, is a particular specimen a human ancestor or not? And so he is going to argue, quote, Australopithecines have generally been regarded as subhuman because of their small brain size. Back to that. But this would be invalidated if it could be shown that they had been tool makers. Oakley is going to make an important distinction between tool use and tool making. He is going to suggest Dart's evidence really is becoming convincing that the Australopithecines might have used tools, but he was very skeptical that they made tools. This argument that Oakley makes, that if we could demonstrate tool making, that would convince us, Dart begins to accumulate all the existing evidence that Australopithecus had used tools, and this is actually a display of bones that he discovers at Makapansgat that show evidence of having been modified or used as tools. This generates a quick response. Wilfred Le Gros Clark, professor of anatomy at Oxford University, who had published many books on human evolution. By the late 1950s, Clark was entirely willing to accept Australopithecus as a bipedal human ancestor, but he entirely rejected the idea of bone tools that Dart was presenting. Likewise, Sherwood Washburn, one of the leading professors of paleoanthropology in America at Chicago, soon to be at UC Berkeley. Washburn in 1955 travels to South Africa, actually goes to 2 national parks to examine hyena dens, comes away convinced those modified bones that Dart was using as evidence that Australopithecus used tools. Washburn was arguing that this is exactly the kind of damage that you find to bones gnawed by hyenas. Washburn is going to argue the Australopithecus bones at Makapansgat, just like the antelope bones, they were actually brought there by hyenas. In fact, Australopithecus was not living in caves. They had been eaten by hyenas who brought the Australopithecus skeletons as well as the antelope skeletons into these caves. Okay, I need to wind up. Washburn and his work essentially long-term settles the question that the antelope bones were in fact collected by hyenas. And this creates a whole type of research on how our bones modified by water, geology, and animals. But by 1960, what we do see, Oakley, Washburn, LeGros-Clark, they had all become convinced not only that Australopithecus was clearly a human ancestor, Dart's effort had finally prevailed, but also every one of them was now open to the idea that Australopithecus had, at least at some simple level, used tools, but they really emphasized the distinction that they did not make tools. But what this did, this contributed to a debate that was emerging in the 1960s over at what stage of human evolution did tool use emerge. And it turns out that Dart's work on Australopithecus, which I have always argued in several publications, that Dart's work on the Makapansket bones and bone tools, this was always about trying to convince people that Australopithecus was a human ancestor. He prevailed in that. But his emphasis on tool use and his conception of human evolution where bipedalism came before large brains and that tool use emerged shortly after bipedalism, this began to change anthropologists' attitudes about when tool use probably emerged in the course of human evolution. Discoveries in the 1970s would finally sort of convince people that bipedalism came first, but also that tool use emerged much earlier than what people had originally thought. And so this connects to my previous, my earlier claim. Dart was wrong. So these were not bone tools, and these were not bones accumulated by Australopithecus hunters. But his research provoked efforts by others to disprove him that actually provided fruitful avenues of research that did actually lead to radically new ideas about the emergence of not just hominids, but also the emergence of tool use. All right, I have kept you too long. Thank you. More than happy to have questions. Ronald?
Yeah. Yep.
Thank you so much, Matt. Yeah, we have some time for Q&A. Christine and John are going to help me field questions in the room. If you're on Zoom, you can either raise your hand and unmute yourself or submit questions to the chat and I can read them out loud. And I think it would be great if we could start with questions on Zoom. If not, we can go straight to the room. Or we can go to round.
Okay. So you mentioned that this large-scale statistical analysis of the fossil record in the 50s was one of, if not the first of its kind.
Yep. In fact, LeGros-Clark, in his critique of the bone tools, is going to praise the statistical analysis as something that other anthropologists should be doing this.
Right. So beyond whether it was convincing in and of itself, I was curious about the response of the broader community to that method, and whether people embraced it readily, or whether there was pushback on the use of statistics in that fashion, just sort of what was the broader response to that method in the community?
Very enthusiastic, largely because two things. One, from the actual results that Dart's work produced, it kind of proved the value of this kind of work. But secondly, there were a number of questions that paleontologists had had for decades about cave finds, where you almost always had random accumulations of different species. How did these accumulate? How do we understand these bone deposits? And no one had thought that a statistical analysis would offer insights into that. They were mostly we just identify what are the species that are found there. This focus on not just what species are found there, but what parts of the skeleton, and then what processes lead to certain bones being preserved and other bones being modified. People immediately recognized, wow, that really would be helpful in solving these other questions about how are these bone deposits being formed in the first place. It was embraced quickly. And there's a guy named Charles Kimberly Brain, who, beginning at the end of my story in the 1960s, this becomes his whole area of research. He's in South Africa. He's influenced by Dart's work. And he begins to do all of these statistical analyses of these various new Australopithecus caves that really serves as the model for paleoanthropologists all around the world. And so this is embraced early, and as I say, today, standard procedure in doing this kind of work. Very rarely is this episode with Dart invoked in this story.
Hi. So I was wondering if you could speak a little bit on your methods for this project. Did you go through archives? Were there any books that you read that were influential or anything like that?
South Africa is a very long ways away. And Dart published an enormous amount. And so where I started from, an excellent question. And so where I started from was, what was the published material? So I left out some stuff that, there's actually an entire debate that you will very often see referenced, just referenced, to Dart's proposal of bone tools. And I knew about this debate. It's not discussed anywhere except to be briefly mentioned in the heroic Dart story as this unfortunate episode where this talented guy who finds this a tremendously important fossil has this crazy wrong idea. And I told you, I'm intrigued by wrong ideas. And so where I got started was, okay, I want to work on this bone tool subject. And there were exactly two people in this room, Saul and Daniel, who saw my very first presentation to the department, and it was on this subject. What became clear very quickly, and again, this is a good lesson for graduate students starting a project. There was more than enough published material to be able to tackle the problem that I wanted to be able to tackle. And so given the fact that it would require grant money to go all the way to South Africa to look at archival material, when I had a very good sense that much of what I wanted to be able to investigate, I could very adequately investigate from the published sources, led me to just simply stick to the published sources. There are specific kinds of problems and specific kinds of subjects where it would really be obvious archival work would be necessary. For this project, it really wasn't necessary. And given the fact that there were obstacles, I was kind of lucky that, no. So it was entirely published sources. Yeah. That other part of your question, so every book on the history of paleoanthropology always discusses Dart and the discovery of Australopithecus. And so I'd read many of these. I also knew these mentions of this unfortunate wrong theory. And it was never discussed by historians. Another fact about me, I always want to investigate the stuff that nobody else writes about. So, and again, the 5205 students, I've told you this before, 100 people doing Newton, Darwin, Einstein. Why in the world be one more person in an industry? I was looking for something that no one had written about. And if it was not interesting, I wouldn't have pursued it. I did that preliminary investigation and it convinced me, wait a minute, there's actually not only a much more interesting problem here, I also realized that, wait a minute, this wrong theory was directly connected to this bigger question, is Australopithecus a human ancestor? And then I wasn't far into the research before I realized, wait a minute, these are fundamentally connected issues. And both modern paleoanthropologists and modern historians, they have failed to make the connection that what Dart was doing in the last half of his career was actually still connected to his failures of the first half of his career to convince people that Australopithecus was a human ancestor. And so that's how I saw there's a project here.
Arian, would you like to ask your question?
Yes. First, thank you, Dr. Goodrum, for this amazing presentation. I have two questions. So first, my first question is, Dart's theory about hunting and tool use was eventually disproven, yet it led to valuable new lines of research. I would like to know, do you think incorrect theories are necessary drivers of progress, especially in paleoanthropology? And my second question is, Dart shifted from anatomical argument to a behavioral one, emphasizing hunting and tool use as a defining human traits. So given that later research suggests that hyenas, not Australopithecus, were responsible for the bone accumulation, do you think paleoanthropology overemphasized hunting as a key marker of humanity? Like with the contemporary definition, how does this debate inform our current understanding of what makes a species as human?
So Sherwood Washburn, the last person that I had the slide for, he is actually very well known for two things. One, he did lots of ape studies, primate behavior studies. But the other thing he was very famous for was he proposed a thesis called the man the hunter thesis, where he very strongly argued that one of the most important events in the evolution of human behavior was the transition from apes being frugivores, eating fruit, vegetables, to hunting and eating meat. And his argument there was not just that changing behavior around what you ate was important. He made the case that it fundamentally changed early hominid behavior. If you observe apes in the wild, it does not take a lot of collaboration to pick nuts and fruit off the ground. Hunting a big game animal, that requires collaboration. In fact, one of the things he's going to argue, it would really be great if you have language. And again, in the evolution from humans to apes, what's one of the quintessential steps? Appearance of language. So Washburn is going to be an advocate of this idea that hunting emerged late. He was very much, Australopithecus might have scavenged, but they didn't hunt. But indeed, hunting, and I'm also convinced of this now too, also not often mentioned in stuff about Washburn. Washburn is responding to Dart. Washburn's responding to this whole debate about Australopithecus. And so for him, hunting sort of exemplifies this crucial stage in human evolution precisely because hunting transformed behavior in ways that made much more ape-like type behavior into much more human-like behavior, because you need collaboration, you need a base camp to bring your animal to bring back to butcher. And so for him, hunting is one of these important events in human evolution. Only occurs once you are past the intermediate ape stage of human evolution and crucially can be identified in sort of the fossil records by archaeological evidence of knives, flint knives, flint spearheads. And so you can also, this is again one of the problems with behavior. Behavior doesn't fossilize. What kind of archaeological record can you find to demonstrate behavior? And hunting provides an archaeological record that you can actually make a case for hunting.
Would these bone tools actually
Thank you.
do any shape repetition?
Yes, they're very adamant about being on the microphone. Well, what was and again, Arjen, what was the first question?
Yeah, my first question was so dark theory eventually was disproven. So
Oh, right.
Yeah.
Remember in 5205 when we were talking about Big Bang theory and steady state theory? And steady state theory is wrong. Now no longer accepted. Yes, I'm in a room full of people where I need to be careful how I phrase these things. But remember, so one could in fact, I think, write a quite interesting book on not just theories that were wrong, but widely held theories that were eventually disproven, rejected, displaced by other theories, where you could also show it was the provocation of the theory that certain people think was so wrong, I'm actually going to shift my research to try to disprove this theory, that ends up doing the kind of research that might not have been motivated to do otherwise, that then produces the kind of evidence that then advances a whole new set of ideas. And so I think it would make an interesting project, not for me, that covering a wide range, because you said paleoanthropology, okay, there would be a few examples, but in the sciences generally, there are like many examples, and I think it would be a fruitful way of actually doing a kind of science that showed we should be paying attention to ideas that were discarded as much as the ideas that are sort of influential or accepted today. And indeed try to show how in many cases, not just they were discarded, but they were fruitful, despite being discarded. And oftentimes, and I really am kind of also intrigued by those people who like fundamentally opposed to something so strongly that I'm going to do all my effort to try to disprove this thing. And it ends up spurring research that others would not have undertaken given like the directions that research was taking normally. And that it sort of, unexpectedly produces this new data that, wow, this actually opens up entirely new avenues for research and entirely new theories about, this particular science. A project
Great.
for you.
Thank you.
All right, I will just ask one question, but I definitely have a lot.
I'm unsurprised.
But I think I have a question about the hyena theories.
Okay.
Because at the beginning, it seems to me, the hyena theory seems to me is like a strategy to disprove Dart's theory to using.
To some extent.
Yeah, but then later, people looks like there are also some development on the hyena theories. So I'm kind of like curious about in general, the animal behavior or this kind of herd migration or animal behavior kind of theory built on the archaeological evidence during that time. Because I think, yes, at one point you can say, yes, it's kind of like a background noise, so it might just cover what Dart really found in the cave. But on the other hand, if we can have another like animal or hyena behavioral theories that can disprove this kind of cave behavior, then probably Dart's right. Maybe they are used to be a tribe in the cave and they accumulate a lot of antelope bones there. Yeah.
So, a lot to say. Always so much more than you can include in a talk. So, von Königswald, that German scientist who first proposed the hyena theory. The National Zoo in Vienna, there was a Viennese zoologist, Helmut, I forget his last name, who was actually studying the captive hyena at the Vienna Zoo. And von Königswald knew this guy. And one of the things that von Königswald observed when he was at the Vienna Zoo, looking at the hyenas, was how they cracked and ate bones. And so there was a place from which von Königswald was coming that was based on empirical information. So yes, he was looking at Dart's claims about these bone accumulations and he was skeptical. It's one thing to be skeptical, But he also had this other source of information. Wait a minute, I've seen this hyena behavior at the zoo of all places, and this looks like a viable explanation for this other thing that I think needs another explanation. And so, but that is a very long way from actually demonstrating that that's the best explanation, which is the beauty of then Dart deploying Hughes to go out and study all these hyena dens, which actually for Hughes, here's the big problem. Here's what ended up being one of the problems. Modern brown hyenas are not extinct Ice Age hyenas. We have to make an inference that modern hyena behavior corresponds to Ice Age hyena behavior. And any good scientist will tell you that's an assumption. And so there was that obstacle, but they're doing all this research to try to empirically disprove the hyena hypothesis. What is very interesting about Oakley and about Washburn, it is not so much the empirical evidence. They are just fundamentally really skeptical that Australopithecus hunted. But you still got these bone accumulations, which makes the hyena hypothesis so appealing. Here is this wonderful explanation that accounts for things, and we can all move on. Now, thanks to Ronald's question. So what happens after this debate? It is, in fact, Charles Brain's work where, and again, I sort of mentioned that he does all the statistical analysis, but the other thing that Brain is going to do, and again, I got to write this paper, entirely motivated by Dart. Brain is all, you know what the interesting thing about Brain? He is convinced that Dart's right about 90% of what he's been saying. He's also convinced that the hyena hypothesis is right. So Australopithecus is a human ancestor. They very likely did use tools. Probably didn't hunt. But how do we resolve the question? So in addition to the statistical analysis, he is going to invent a brand new science called taphonomy. What happens to an animal that dies in a cave? It decays. What are the weathering processes that can cause small bones to just simply dissolve? So why would you find certain kinds of bones and not others? Very small bones are going to dissolve just from weathering. Number two, are certain parts of the skeleton going to fossilize more often than other parts of the skeleton? Turns out some parts of your skeleton are very thick, heavy bone. Other parts of your skeleton are very porous, spongy bone. Those spongy kinds of bone, they often don't fossilize well. And long term, they will disappear from the fossil evidence. It's the cranium, it's arm bones, leg bones, pelvis that survive. Fingers, toes, certain parts of other bones, they're gone. There are regular natural processes that will allow us to explain why certain bones survive, other ones don't. Lastly, this whole deal, the slide with all of those modified bones that look like it was used as a dagger, as a shovel, as a spoon, as a dish, he very convincingly showed porcupines have this annoying habit of going into caves, and because of their teeth, they need to gnaw bones. And they gnaw bones in ways that produce sharp-pointed ends just like a dagger, that produce these sort of scoop marks that Dart was identifying as, oh, this would actually make like a nice spoon. And he showed that leopards' predation and hyena eating also modified bones in ways that made them indistinguishable from human tool use of bones. It's Brain's work that really settled. Dart was wrong about the bone tools, and here's how we can show why. But in doing so, again, produced a whole new science. We need to be able to understand what happens to bones in the process of being fossilized, to be able to explain these bone accumulations that anthropologists and archaeologists keep finding with these weird statistical anomalies that might indicate. So back to part of your question, you can look at sites where we know early humans did live. They are hunting animals, eating animals. What kind of remains are left behind at a campsite? Compare that to statistical analysis. Compare that to the statistical analysis of a cave where there wasn't human activity. What brain shows is they're going to be very different accumulations. And now I can explain what are the processes that produce the human cave site and the natural process. Weird statistics. For various reasons, jaw bones are actually very easy to fossilize, but also when you're carrying a carcass back to a cave, tends to be part of the carcass that gets carried back to the cave. And so there are natural mechanisms to explain what's going on. That is provoked by DART. It's happening in the 1960s, and it's brand new. As I said, whole new discipline, taphonomy, that again, if you're going to be if you're a paleontologist or an archaeologist today, you actually now have to study taphonomy. This begins with DART. And again, I've seen no other account that it goes back to brain. They never connected, but brain was motivated by this whole episode with DART, because everybody always views the DART story as the 1925 paper and the eventual acceptance, and then his unfortunate sort of episode with the Makapanskit stuff, which is disregarded. It's always disregarded. But now, connected to the first part, but also leads to this other stuff. And so, yeah. Good question.
I think we have time for one more question, and we have a question on Zoom from Monami.
Hi, Matthew. Thank you so much for your talk. It was so lively, and I was really riveted. And you're such a great storyteller, so thank you very much for just sharing your work, and I learned so much.
Thank you.
I don't know if there's actually time to answer this, and I don't know if it's within your ambit to answer this, but as you were talking, I was just really curious. You said you started off with, this is a story about evidence. And, when I think of evidence, I also think about power and politics too, in addition to evidence. And in finding this piece of history that has not been uncovered by other historians, I was wondering about how you thought about the wider political, happenings that were going on at that time and how that shapes evidencing. I think there was something about Darwin thinking that Africa had a hunch that Africa was the cradle of civilization or something. And I know South Africa was vested in that, and I was thinking maybe that contributed to European scientists or in the, at the core, discounting things like what Raymond Dart was facing or finding, and just thinking about what the broader politics were. I was thinking of forensics too, and thinking about what murder detective work was being drawn on, and like how people were thinking about, and like all sorts of things that were going on at that time. So just wondering if you could talk about that. I don't know if there's time, but that's something that was really struck me as interesting too.
So I'll mention two things. So indeed, when Dart publishes The Descent of Man, almost entirely because if you look at the existing species of ape, Dart was convinced that humans are anatomically most like chimpanzees and gorillas, which live in Africa, and not orangutans and gibbons, which live in Southeast Asia. And so he, in The Descent of Man, we're probably going to find the human ancestors in Africa because our ancestors were probably related to chimpanzees and gorillas. Within 20 years, Ernst Haeckel is going to make the case that no, orangutans are much more like humans than chimpanzees and gorillas. And then there is going to be this argument, now to really get to your interest, partially motivated by European imperialism and racism, some reluctance that you can see that's not explicit but present among European scientists of having humans evolve in Africa rather than out of Africa in some place like Asia. And so racist anthropological ideas of the late 19th century plays some role there. But it's more complicated than that because it's also in this notion of, but there's apes in Asia, okay, great, but also, why didn't apes in Africa stop being apes and evolve into humans? And the argument there was because apes live in jungles, in rainforests. Africa still has rainforests, and so there was no environmental push to transform apes into humans. Whereas in Asia, during the Ice Age, there was always the same language, mon ami. It was a challenging natural environment that provoked these early ape-like humans to develop new lifestyles, greater intelligence, and it was this challenging natural environment that provided the impetus to evolve into humans. That exists in Asia, doesn't exist in Europe. So it's a combination of scientific factors supporting this, but also, yes, political, imperialist, racist factors. Much more relevant to DART by the time we get to the 1930s and 1940s, though. I reviewed a very nice book by a woman named Christine Collegiate on DART and Tobias. That book is entirely on, and again, I have an aversion to wrestling with this. DART is in South Africa precisely in the transition from being a British colony to being an independent state, but also more crucially, he is in South Africa in the change in government to the apartheid government. And Collegiate has written this very nice book of DART as an anthropologist in a racist apartheid South Africa where anthropologists were used by the government to make determinations of race of citizens of the country that were racially ambiguous, because what their race was determined what their political state was going to be in the country. There is that whole dimension to DART, to Philip Tobias, to all these anthropologists that are in South Africa during this period, that it's an important story for a historian to tell, absolutely not the kind of story that I want to get involved in. It requires skills that are not my set of skills.
Fair enough. Thank you so much for the response, though. That was great. Thank you very much.
And 3 on the dot.
Thank you so much, Matt. I'm sure
Thank
if
you.
there are more questions in the room, you can answer them later. Just a quick announcement before I leave the Zoom is that next week we don't have a seminar, so we will resume on February 21st. Thank you so much.
Became paramount. Remember I said I was going to bring back a history angle?
Yep.
I was going to do population genetics.